7, 6, 5, 4, 3, 2, 1, ignition, and liftoff of Falcon 9. Go SpaceX, go SDA.
Vehicle is pitching downrange.
And 1D chamber pressure nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 4 East at Vandenberg Space Force Base in California. We're now throttling down the engines to prepare for max Q, which is the point of maximum aerodynamic pressure
Power and telemetry nominal.
During ascent, and good call out there for nominal telemetry. Now, max Q occurs when the combination of speed and air pressure puts the greatest stress on the vehicle.
Vehicle is supersonic.
There's that call out that the vehicle is now supersonic, going faster than the speed of sound. We should be hearing that call out for max Q in just a few moments from now.
Max Q.
And there's that call out for max Q. Now, coming up next, we'll have a few events happening in quick succession, starting with MECO, followed by stage separation, and then SES-1. Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down on the booster to slow the vehicle down in preparation for stage separation, which is where the first and second stages separate. Following this...
MVAC chill.
And good call out there for MVAC chill. Now, following that, the MVAC engine on the second stage will light, which is called out as second engine start 1, or SES-1. Now, this engine burn lasting several minutes will propel the second stage and the payload to orbit. And in addition to these major events, the fairing halves will separate about 50 seconds after SES-1. Now, as a reminder, we will not have any views of the Falcon 9 second stage or the payload at the request of our customer. Now, this series of events, again starting with MECO, is set to begin in just about 15 seconds from now.
Stage separation confirmed.
Main engine cutoff. MVAC startup.
And there we heard that series of back-to-back callouts, which again were MECO, followed by stage separation, and then SES-1. And coming up shortly, we should hear a callout for fairing separation, but as a reminder, we will not be showing it on screen. As I mentioned earlier, both of the payload fairing halves supporting today's mission are flight proven, with one half flying for its 6th time and the other for its 5th.
Fairing separation confirmed.
And there's that confirmation of fairing separation. Those fairing halves will now fall back to Earth, and we will attempt to retrieve them with our recovery vessel, Go Beyond. If you're just joining us, you're watching live coverage of the SDA Tranche 1 Launch 3 mission. To recap the mission so far, we had an on-time liftoff at 1:32 p.m. Pacific Time from Slick 4 East at Vandenberg Space Force Base in California, and had successful stage separation of our Falcon rocket. And we've got some wonderful views of the California coastline there on your screen. Now, up next will be the return of our Falcon 9 booster to Earth. In order to make its way back, the Falcon 9 first stage has 2 more burns it needs to execute. First up will be the entry burn, which helps to slow the stage down as it re-enters the upper part of the Earth's atmosphere. And then following the entry burn shortly thereafter, the booster will initiate the landing burn, which will slow the vehicle down for a soft touchdown on our drone ship, Of Course I Still Love You, currently stationed in the Pacific Ocean. We're expecting that entry burn call out at around the T plus 6 minute and 23 second mark. Now, to start the entry burn, we'll be relighting 3 M1D engines, which is similar to pumping the brakes to slow down the vehicle as it passes back into Earth's atmosphere. We need to slow down the vehicle to reduce re-entry forces, which then helps us recover and reuse that first stage. Now, during the entry burn, Falcon 9 is decelerating by firing its Merlin engines in the direction that it's moving. and this causes the rocket to fly through the engine's exhaust gases, which deposits a layer of soot on the vehicle's skin. And this is what gives our flight-proven vehicles their characteristic look. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. Now we're just under a minute and a half away from that entry burn, and you can follow the telemetry at the bottom of your screen. On the left-hand side, we can see the vehicle speed and altitude, and the right-hand side will show the engines that'll relight once that entry burn starts. Falcon 9 is also equipped with 4 hypersonic grid fins, and you can see them from time to time with the views on your screen. And those are positioned near the top of the first stage and are used to steer the vehicle as it returns to Earth. These are the primary aerodynamic control surfaces for the first stage during atmospheric reentry and descent, and are a critical part of Falcon 9's reusability system. From time to time, you might also spot white puffs coming from Falcon 9, and those are the cold nitrogen gas bursts, which help with attitude control. Now, reusability is key to lowering the cost of spaceflight, enabling more investments in critical space infrastructure. As I mentioned, the Falcon 9 first stage supporting today's mission is about to perform its entry burn for its 4th time. And we should be hearing that call out for entry burn in just about 10 seconds from now.
Stage 1 FTS is saved.
Stage 1 entry burn startup.
And there's that call out for entry burn startup on the Falcon 9 first stage. This burn is set to last about 26 seconds, and again is slowing down the vehicle in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And there's that call out for entry burn shutdown, signifying completion of the Falcon 9 first stage entry burn. Now, the Merlins on the Falcon first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon's first stage has thrust greater than 5 747 airplanes at full power. The single MVAC engine on the second stage has a much wider nozzle, and it's optimized to operate in space, producing 220,500 pounds of thrust in vacuum. Now, coming up shortly, just about 40 seconds from now, we'll have the start of the landing burn of the Falcon 9 first stage. And as I mentioned earlier, this is the final burn the booster will perform on today's mission, and it's used to reduce the remaining speed of the vehicle for a gentle and precise landing on our drone ship. Of course, I still love you.
Stage 1 transonic.
There's that call out that stage 1 is now transonic. We'll have a soft and gentle touchdown on our drone ship, Of Course I Still Love You, currently stationed in the Pacific Ocean. Now we should be hearing that call out.
Stage 2 terminal guidance.
And nominal call out there that stage 2 is in terminal guidance. We should be hearing that call out for the first stage landing burn in just about 10 seconds from now.
Stage 2 FTS is saved.
Stage 1 landing burn.
And there's that call out for the landing burn startup of our Falcon 9 booster.
Stage 1 landing leg deploy.
And vac shutdown.
Stage 1 landing confirmed.
And another successful landing of our Falcon 9 rocket.
Nominal orbit insertion.
And there's that call out for nominal orbital insertion of the second stage. Now, as a reminder for the booster, this was the 4th launch and landing for the booster supporting today's mission. Now, as a reminder, we will not be showing any Stage 2 or deployment views today at the request of our customer. So with the successful landing of our booster, we'll be bringing our webcast to a close. We'd like to thank the Space Development Agency for entrusting us with today's mission, as well as the Range and FAA for their support. If you're interested in more launch coverage, be sure to check SpaceX.com/launches and follow @SpaceX on X for the most up-to-date information.